Hi everyone and welcome back. So this question, we have to find the area, find A in terms of x, find A area in terms of x of the shaded rectangle. ORPQ, ORPQ. So I'm going to go ORPQ. So we know in order to find the area of rectangular shape, it's pretty much what we do is base times height. In this case, base would be x. X, how do we know that? Because this point here is x. So if I said here 2, it means my horizontal line is equal to 2. And if I have 1 here, it means my vertical line is 1, but in this case is just y. So pretty much this is y and this is x. So it's going to be x times y. And we can say, yes, that's it, we have it. However, those questions that, or this one that we are doing, is the question where we use for optimization, where we either have to minimize or maximize something. So in this case is the area, and in terms of x. Which means pretty much that we have y here that is getting in our way. So we want this area, everything in terms of x. So, as I said, we have to get rid of this y, but we can't just delete it. So we have to find this y in terms of x's. So how are we going to do that? Let me just, tidy up this a little bit. It's, yeah, like that. Okay, I'm just going to go, yeah. So what we're going to do, we're going to look at what is given. So, and I'm going to take a few things out here. So we have, looks like triangle, doesn't it? Okay, so big triangle, so right angle triangle. So this height here is 5, okay? So from here to there, 5. Right, this is 5 on y-axis, which means this length is 5 units, whatever units we have. So then this here from 0 to 10, all that length is equal to 10 whatever units. Now we can see inside we have, so this is rectangular shape, but when we have this rectangular shape inside, we are creating another triangle that is a little bit smaller. So I'm going to use different color. What color are we going to use? Let's go with green. So this is another one. So I'm going to have like sort of inside, yeah. I'm going to label, so I'm going to put here, all this is 10. 10, and then I'm going to label this smaller triangle. So let's have a look. Is anything else given? So what do we know? We know that this is x from here to there, because this is the point P, has coordinates x and y. So this is x. If this is x, then what's left there is 10 take away x, isn't it? Yeah. So I just like these lines here. And when I did drafting back in Bosnia, those lines needed to be at 45 degrees. So now we can see what we have here is actually similar, two similar triangles. So similar triangles, those two triangles have the same angle, the common angle, so they're sharing this angle, and they do have another angle exactly the same, which is right angle triangle. So similar triangles, we do know that the ratio of corresponding side is the same, so corresponding side. So what we're going to do here, so if I start with 5 over 10, is this what I have here? Let me have a look. Yeah, okay, this height here, this is y. Yep. Okay, beautiful. It's just this y looks a bit weird. I'm gonna go like that. So corresponding side. This 10, this length, divided by this length. So we're gonna go, okay, let's use now this 10 divided by 10 take away x. So 10 take away 10 divide by 10 take away x. So that's first ratio. So we started with the bigger one, with the 10, which means now in numerator we're gonna go with bigger as well, a triangle, which is 5 divided by the height of the smaller one. In this case is y. Now we want to find y by itself in terms of x. So we can multiply, cross multiply. So that's going to be 10y. There are different methods to use here. So you can use whatever you prefer. In my opinion, the easiest one is cross multiplication. Not that there's much understanding here, but you know, if you have done a little bit of algebra, which you should have by now, so I don't need to explain why we can use our cross multiplication. So now we have 10y, we need y by itself, y is equal to, okay, I'm still gonna actually have 10y because I would like to expand this side. And now I'm gonna divide by 10 everything, so it's gonna end up with 5 take away half x. So this is our y. Now let's go back to the area, which is just here, just there. Okay, this is the area, and I'm gonna do it like here. So area is of this rectangular shape is x times y. However, we said we want to find the area in terms of x, and we have y, it's getting in our way. So we're gonna go like x. Now, instead of this y, this one here, we're gonna come here, you know, take this one here, you know, like hook, and then put it back into y. So replacing y by all this value. So instead of y, now we're gonna have what? Yep, that is right. 5 take away half times x. Let's expand this. Area is equal to 5x take away half x to the power of 2. So that would be the final one. Sometimes you may see, you know, having this number first, because often in quadratics first we put the variable with the highest power, which is in this case is x to the power of 2, but it's exactly the same, doesn't make any difference. Or you may have seen this a of x, so in terms of x's. And that would be all for this question. So now, if you wanted to maximize this area, so you would have to find derivative, etc., which you're gonna see later in the course. Okay, that would be all for this question, and I'll talk to you soon. Bye.